Hello everyone, today we're going to look at connected particles. So what do we mean by a connected particles? So this could mean that the particles remain in contact. So it could be just be two particles attached to each other. So or it could be two particles connected by an inextensible rod or inextensible string. So this is what we meant by connected particles. So it could be two particles connected by an inextensible rod or string. So in this case, when the particles are connected, we can consider the particles as a connected particles that moving in the same straight line. So moving in the same straight line just means that they're traveling horizontally on a straight line, or they're traveling vertical in a straight line. So when connected particles moving in the same straight line can be treated as a single particle. So they might have different masses. So for example, this might be 3 kilograms, this is 5 kilograms. As long as the particles are connected and moving in a straight line, we can treat those two particles as one particle. So let's look at example 1. So I have two particles, P and Q, of mass 5 kilograms and 3 kilograms, are connected by an inextensible string. So let's sketch our diagram. So I have I have a particle. So let's call this particle Q. And I have another particle P. So let's call this P. So the mass of P is 5 kilograms. So remember writing in the order. So P is 5. So 5 kilograms. And Q is 3 kilograms. And they are connected by a light intensible string. So they are connected by a string. Then we're told that particle P is pulled by a horizontal force of magnitude of 40 newtons along a rough horizontal plane. So we have a force pulling particle P with 40 newtons. And we're told that is along a rough horizontal plane. So let's just draw a horizontal plane. Then we're told that the particle P experiences a frictional force of 10 newtons. So remember, frictional force are the backward force that's slowing the particle down, and it's 10 newtons for P. So backward force of 10. Then we taught particle Q experience a frictional force of 6. So again, frictional force of 10. Of 6 for Q. So we just filled in the information from the question. So let's fill in our diagram. So as we know, it's gravity force. So as we know, the weight is equals to mass times by gravity. So weight is going down, so be 5g. Similarly here, weight is going down, and this is, as we remember, weight is equals to mass times by gravity, so the weight of this is 3g. And we know there are reaction force, so I'm just going to call, so there is the normal reaction 1, and let's call this normal reaction 2. So remember, this is, so we just sketch our diagram, and let's just another thing. So since it's connected by the string, so we have tension, so let's just in the middle, so imagine, so because it's connected by a string, so we actually the second particle is pulling it back, and the front one is pulling this particle forward, and we call this the tension. So we have our tensions as well. So let's work out the question. So part A, find the acceleration of the particle. Since the particle is connected by intensible string, we can consider the two particles as one particle, because that's our definition. So connected particles moving in a same straight line can be treated as a single particle. So we can treat this as one particle. So we can find out the acceleration. So the question asks us to find the acceleration of the particle. So remember Newton's second law. So F equals ma. So we want to find out the acceleration. So firstly, we need to work out the resultant force. So let's work out. So we have, so the particle is pulling 40 newtons. So we have 40. So it's going in this direction. So our resultant force. So we always use the bigger number, subtract the little number. So force forward is 40. The minus are 10 friction and minus are 6 friction. So this is our resultant force, and it is equals to mass. So the total mass of the two particles are 3 plus 5. So the total mass of this new particle is 8, and multiplied by acceleration. So you'd have 40 minus 10 minus 6 is 24, equals to 8a. Therefore, your acceleration is 3 meters per second. So let's look at part B. Find the tension in the string. So the tension, so we can either pick particle Q or particle P, it doesn't matter. So let's try both, so I can prove to you that no matter which particle you